Hello, now let us solve the problem together. In the first problem, we are supposed to calculate this integral. Okay, so you see that the derivative of cosine x appears as a factor in my integrand. So this indicates me that the method of substitution is the best way to solve this integral. Yes, so what I do, I would say that let u be cosine x. Then I differentiate both sides, so du becomes minus sine x dx. The derivative of cosine is negative sine. And then you see that I need the combination of sine x times dx, so it motivates me to multiply both by a minus sign, by -1, so this is what I need. And then the only thing that I have to take care is the new limits, because these 0 and pi over 3 are the limits of the old variable x. So this implies that the limits for the new variable are, if x is 0, I put 0 here, cosine of 0 is 1. If x is pi over 3, I put this here, cosine of pi over 3 is 1/2. So now the question mark that I'm looking for is just integral. Instead of going from 0 to pi over 3, I go from 1 to 1/2. And then instead of sine x dx, I can put minus du, but negative sign, I can pull it out, and I put du here. And instead of e to power 2 cosine x, I just simply write e to power 2u. But this is a very simple integral to calculate. So this becomes negative sign here, and the primitive function for that when u itself is variable is 1 over 2 e to power 2u. I have to calculate it from 1 up to 1/2. So what I do, I replace every u with the upper limit, so it becomes minus 1/2 e to the power of 1, minus, I replace u with 1, it becomes minus 1/2 e to the power of 2. And if I simplify that, this becomes positive, so it becomes e squared divided by 2. This becomes e divided by 2 with a negative sign, so the answer would be e squared minus e over 2. So that's the final answer to this problem. Okay, now let us go to the next one. We are supposed to calculate this integral. So you see that this is a rational function, and the degree of the numerator is 0, the degree of the denominator is 2, so the degree of the denominator is more than the degree of the numerator. Whenever this happens, the best technique to solve the problem is probably using the partial fraction method. So this means that first of all, I would decompose this fraction into partial fractions. The first thing that I have to do is to factorize the denominator. So this denominator is a very simple polynomial to factorize. I put 2 x's here and there, and then I ask myself, I need two numbers whose sum is positive 1 and the product is negative 6. So one of them is obviously plus 3 and the other one is minus 2. When I add them, it becomes positive 1. When I multiply them, it becomes minus 6. Then I use the method of partial fractions to decompose this fraction into the sum of two simpler fractions. So I would write it like this. I put this in the denominator of the one of them, and then x minus 2 in the other denominator, and here I put a constant a and a constant b here. My goal is to determine constants a and b. Okay, so you can momentarily ignore this one, and then what I do, I multiply both sides of this equality by the fraction of the first one. If I do that, the fraction will go on, 5 is left. On the right hand side, when I multiply this fraction by this expression, x plus 3 here will cancel that x plus 3, x minus 2 is left, which will multiply to the numerator. This becomes a times x minus 2. And for the same reason here, x minus 2 will cancel x minus 2, x plus 3 survives, which will be multiplied to the numerator. And then I expand the right-hand side, so it becomes ax minus 2a plus bx plus 3b, and I reorder it because I want to write it as a standard first degree here polynomial. I don't want to have x in two positions. I want to combine them so that I can compare the right-hand side and the left-hand side. So between these two, I factor 1x out from here, a is left, from there, positive b is left. And these are my constant terms, so I can group them together. I can write 3b minus 2a. Then my goal is to fine-tune these constants, a and b, so that the right-hand side becomes identical to the left-hand side. It means that for every choice of x, the right-hand side should match with the left-hand side. This cannot happen unless the coefficients of this correspondingly match with the coefficients of the left-hand side. So here, there are no x's, so this means that a plus b, which is the coefficient of x here, should be 0. And then I get this term, should be 5. So this means that 3b minus 2a should be 5. But from here, for example, I can see that a is negative b. I can put it here, so this becomes 3b minus 2 times minus b is positive 2b is equal to 5. So this means 5b is equal to 5, and then b becomes 1. And when b is 1, I put it back here, a becomes negative 1. Yes? Okay, and then what I'm supposed to do, I replace here, this is the fraction that I have, so let me write it here. So the fraction that I have is 5 over x squared minus x plus 6. This is equal to this fraction where a is minus 1, so it becomes minus 1 over x plus 3, and then plus that fraction where b is 1, so this becomes plus 1 over x minus 2. So because this fraction is equal to the sum of these two fractions, the integral of the left-hand side is the integral of the first one plus the integral of the second one. So this means that the integral from 0 to 1 of 5 over x squared minus x plus 6 dx is equal to minus integral of 1 over x plus 3 dx from 0 to 1 plus integral from 0 to 1 over x minus 2 dx. But these are quite famous integrands, so you know how to find the answer. So a primitive function for this is just simply ln of absolute value of x plus 3. I have a negative sign here, and it's supposed to go from 0 to 1. The same thing more or less for this one. So this is also ln of absolute value of x minus 2, and I have to run it from 0 to 1. Okay, and then what I do, I replace x with 1, so this becomes minus ln of 4, and then I replace x with 0, so this becomes minus ln of 3, and then I have to subtract these. So this is the answer to the first integral, and for the second one I will do the same thing. So if I replace x with 1, it becomes negative 1, but the absolute value of negative 1 is just 1, so this becomes ln of 1. And then minus, I replace x with 0, ln of minus 2 absolute value, it becomes ln of 2. Okay? And if I simplify this a little bit, what happens here? This becomes positive ln of 3, this becomes negative ln of 4, but ln of 4 can be written as ln of 2 to power 2, so these 2 go to the back. The reason that I want to do it, because then I can have a chance to simplify it with the last term. Okay, so this becomes 2 ln of 2, and then instead of this, I would write minus 2 ln of 2. Yes, am I right? Yeah. And then ln of 1 is 0, minus ln of 2. So the answer becomes ln of 3 minus 3 ln of 2. Okay, that's okay. That's the answer. But if you want to go a little bit further, for example, you can write it in the form of 1 ln. Yes, how? So I can write it ln of 3. I move this 3 on top. So this becomes minus ln of 8, and then instead of writing this, I can simply write ln of 3 over 8. So might be that's a better idea to simplify this a little bit and get this answer. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.